Hello friends, let us begin the concept of Maclaurin series. In the later videos, we will see the Maclaurin series is nothing but the particular case of Taylor series. So let us see what is Maclaurin series. So if fx is a function which is differentiable, in fact it should be differentiable any number of times. Then it can be expanded in a ascending powers of x, and that is called the Maclaurin series. So it is like this: fx is equal to f of 0 plus x f dash 0 first derivative plus x square by factorial 2 f second derivative at 0 x cube by factorial 3 f third derivative at 0 and so on. So this is called the Maclaurin series. It can also be like this: if y equal to fx, then this we can say that y at 0, then this is y1 at 0 plus x square by factorial 2 y2 at 0 x cube by factorial 3 y3 at 0 and so on. So let us find some standard Maclaurin series of some standard functions. So obtain Maclaurin series of fx equal to e power x. Hence, obtain Maclaurin series of fx equal to cosine hyperbolic x. Hence means we have to use the Maclaurin series of e power x to find the Maclaurin series of cosine hyperbolic x. So here fx is e power x and value of f at 0 is e power 0, and that is 1. Its derivative at x is also e power x, so its value at 0 is 1. Second derivative is also e power x, its value at 0 is 1, and so on. Third derivative is also e power x, and its value at 0 is equal to 1, and so on. So Maclaurin series is fx is equal to f at 0 plus x f dash 0 x square by 2 factorial f second derivative at 0 x cube by 3 factorial f third derivative at 0 and so on. So e power x is f at 0, everything is 1. So 1 plus x square by factorial 2 x cube by factorial 3 and so on. These are all values 1. Now we would like to find the Maclaurin series of cosine hyperbolic x. And we know cosine hyperbolic x is nothing but 1 by 2 e power x plus e power minus x. Now this is the Maclaurin series of e power x. You can find the Maclaurin series of e power minus x just by replacing x to be minus x. Wherever there is x, you put minus x. So this is 1 plus minus x plus minus x square by factorial 2, x cube by factorial 3, and so on. So this is 1 minus x plus x square by factorial 2 minus x power 3 by factorial 3, and so on. Now cosine hyperbolic x is 1 by 2 e power x plus e power minus x. So series of e power x is 1 plus x square by factorial 2, x cube by factorial 3, x power 4 by factorial 4, x power 5 by factorial 5, and so on, plus e power minus x. So that is 1 minus x plus x square by factorial 2 minus x cube by factorial 3, say plus x power 4 by factorial 4 minus x power 5 by factorial 5, plus and so on. Now here, this term will be getting cancelled, x and minus x cube by 3 factorial minus x cube by, this term will be getting cancelled. Now 1 is here, 1 is here, so that will be 2 times. Then x square by factorial 2, x square by factorial 2, so 2 times x square by factorial 2 plus 2 times x power 4 by factorial 4, and so on. So that is nothing but cosine hyperbolic x 1 plus x square by factorial 2 plus x4 by factorial 4, and so on. So that is the series of cosine hyperbolic x by using the series of e power x. Okay, next. So obtain Maclaurin series of fx is equal to sin x. So fx equal to sin x. F at 0 equal to 0. Its derivative is cosine x. Its value at 0 is 1. Cosine 0 is 1. Second derivative is minus sin x. Its value at 0 is 0. Third derivative is sin x, derivative is cosine x, negative sign is there. So its value at 0 is minus 1. So fourth derivative is sin x. Its value at 0 is 0. So fifth derivative is cosine x. Its value at 0 equal to 1, and so on. So Maclaurin series is f of x is equal to f at 0 plus x f dash 0 x square by factorial 2 f second derivative at 0 x cube by factorial 3 f third derivative at 0, and so on. And so sin x equal to f at 0 is 0 plus x f dash 0 is 1, f second derivative is 0, third derivative value is -1. Then fourth derivative 0 is 0. Fifth derivative value is 1, and so on. So sin x is equal to x, then minus x cubed by 3 factorial plus x power 5 by 5 factorial, and so on. Same way, you can obtain the series of cosine x. It is easy, and you can find that it is 1 minus x square by factorial 2 plus x power 4 by factorial 4 minus x power 6 by factorial 6, and so on. Let us obtain the Maclaurin series of 10x. Fx equal to 10x. So here y equal to fx is equal to 10x, and y at 0 is tan 0, and tan 0 is 0. Now the first derivative y1 is derivative of 10x is x square x, and y1 at 0 is 1, sec 0 is 1. But you can write sec square x as 1 plus tan square x, or we can say 1 plus y square. Now derivative y2. So derivative of 1 is 1. Y square. So 2y, and derivative of y is y1. So y2 at 0 is, you need y at 0, y1 at 0. But y at 0 is 0. So 0 into anything, 0. Next is y3. So 2. Derivative of y is y1, and y1 is there. So y1 square plus 2y and y2. Now y3 at 0. So 2 y1 square. So y1 at 0 is 1. So that is square. And y at 0 is 0. So second term is 0. So that is 2. y4 is y1 square is derivative of y1 square is 2y1 and y2. So that is 4 y1 and y2. Plus this is 2. Derivative of y is y1 y2 plus 2y y3. So this is 6y1 y2 plus 2y y3, and y4 at 0. So see here y2 at 0, 0. Here y at 0 is also 0. So that is 0. y5. So derivative of y1 is y2. y2 is already there, and 6 is there. So 6y2 square plus 6y1 y3 plus 2 here y1 y3 plus 2y y4. So y5 at 0. This is y2 at 0, so 0. Y or y4 at 0, so that is 0. We have it is 8. y1 at 0, and y1 at 0 is 1. And y3 at 0, y3 at 0 is 2. And so 16. And so on. So Maclaurin series y at x is equal to y at 0 plus x y1 at 0 x square by 2 factorial y2 at 0, and so on. X cube by 3 factorial y3 at 0, and so on. So 16 and 0 cancel. So y at 0 is 0. y at 0 is 1. y at 0 is 0. y at 0 is 1. 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 So 10x equal to y0, y at 0 is 0, y1 at 0 is 1, then y2 at 0, 0, y3 at 0 is 2, y4 at 0, 0, y5 at 0 is 16, and so on. So 10x is equal to, this is x, this is 2 and 3 factorial, so 2 to cancel, 3 will remain. So plus x cubed by 3, and this is 16 and 5 factorial, 5 into 4 into 3 into 2. So 4 4 is 16, 2 2 is 4, 2, 5, and 3. So that is 2 by 15, x power 5, and so on. So this is the expansion of 10x. So in the next video, we shall see some more example or more expansion.